All right, let's do another example here. And so we've got three inequalities now. And so we're going to graph all three of them and decide where the solution set is, right? So we're going to graph each one and then decide where we need to shade, okay? And then we can use test points or use the solve it for what or use what we know when we solve for y, right? So here we have a parabola, right? So we have a parabola that opens downward and it's shifted 4 units up, okay? So the parabola is going to be at 4. And when x is 0, y is going to be 4. Right? Or excuse me, when y is 0, right? When y is 0, x is going to be equal to the square root of 2, right? So if we look at this, right, so if we just say, define the x-intercepts, right? So y is equal to 0, so y is equal to negative x squared plus 4. And so that means x squared is equal to 4, which means x is going to equal plus or minus the square root of 4, which is going to be plus or minus 2. So that means the x-intercepts are going to be at here and here. So we have a parabola that does that, right? And since it's equal to, it's going to be a solid line, okay? And since it's less than, we know that we're going below the parabola. So that means that the shaded region is going to be everything below the parabola. Okay, now again, we could pick a test point 0, 0, and we could plug in 0, 0 here, and we find that 0 is less than or equal to 4, which is true. So again, test points will work too. Okay? Now let's do the next one. Now here we can find this is a linear inequality here. Okay? And so if we plot this one, right? So I would let's solve for y. So we'll get, so we're going to subtract x from both sides. So we'll get negative y is greater than or equal to negative x minus 2. And if we multiply everything by negative 1, we're going to flip the inequality. Don't forget that. So anytime we multiply or divide by a negative value, the inequality flips. Okay, so if I multiply everything by negative 1, all the signs are going to change and we're going to flip the inequality. So this will become y is less than or equal to x plus 2. Okay, now we're going to plot the equation, right? And since it's less than or equal to, the line of the equation, the graph of the equation will be a solid line. And so this has an intercept at 2, right? So at 2. Okay, so y-intercept at 2, and the x-intercept is at negative 2. Right there, okay? We can see that the slope is 1, so we can see that 2, right? It's going to be here, and it's going to go here. Right, so we have a straight line like that, okay? So here's the equation, y equals negative x squared plus 4. And here's the equation, x minus y is greater than or equal to negative 2. And since it's less than or equal to down here, now that we solve for y, we know we're going to be below the line. So that means we're going to be everything on this side of the line, right? Okay. So we see that the overlapping is right in here so far. Okay. Now the final one is it says y is greater than negative 5. So this represents, so the boundary line is y equals negative 5. So that's going to be a horizontal line, right? Where? Right at negative 5. Y equals negative 5. So we're going to draw a horizontal line. Okay? And the horizontal line is y equals negative 5. Okay? Now, since it's greater than, we're going to have a dotted line going all the way across. Okay? And since it's also, it says greater than, we're going to be above the line. Like so. So the area where it overlaps is going to be where? It's going to be, the boundary points are going to be right here, where the parabola intersects here, and where the parabola intersects here, and then up to here. Okay, so it's going to be here, like so, and then down to here, and then over to here, and then it's going to be there. And so we find that's everything inside here, right? So everything inside that region is the solution set. And so now, the only thing we need to know that we would like to know are these intersection points. So we need to find this point, this point, this point, and this point. Okay? And the way we find those is by just setting up the equations, right? And finding out where they intersect. Now, we want us to find out where the parabola and this line here intersects. We're going to set this one equal to this one, right? So we're going to set, where is it at? Right here. So we're going to set x plus 2 is equal to negative x squared plus 4. So if we move everything over to the left, we get x squared plus x minus 2 is equal to 0. And so in this case here, the factors that are the factors of negative 2 that will add up to 1 is going to be 2 times negative 1. So this will factor into x minus 1 and x plus 2. And so that means x is equal to 1 or x is equal to negative 2. Okay, and so there's the 2 points, right? So this line intersects the parabola here and here. Notice that it's at -2, right? Right where the x-intercept is. So it intersects there. So one intersection point is going to be what? 1. We just have to plug in 1. So if we plug in 1, we get 3. Oh, right here. So right here. So yeah, 1, 3 is right here. So that's going to be 1, 3. And then the other one is at -2. So when we plug in -2, we get 0, which is right here. So we get -2, 0. So those are the 2 points. And now what we're going to do is we're going to set the parabola equal to the constant. We're going to equal -5, and we'll find out where it's equal to -5, right? So we'll get 2 points here as well. Okay, so let's do that. So we're going to set -x² plus 4 equal to -5. And so now we're going to solve this, and we get -x² is equal to -9, which means x² is equal to 9, and which means x is equal to plus or minus 3. And so now we get those two values, right? So when x is 3, so what happens? When x is 3, well, it's going to be at -5. So they both have to be at -5, right? Because that's what we're solving for. So now the 2 points, the 2 other points are going to be what? -3, -5, and +3, -5. And there are the 4 points that, the corner points of the region, the bounded region of our solution set. All right, that's it. Have a great day.